I hope today you were able to listen to some of the great talks we've had and explore the different sandboxes. And if you haven't seen the smart home section in the Assistant Sandbox, I highly encourage you to do so. Thank you. We have a great team there and some really cool demos, including showing you how the Smart Home API can help you grow a better garden. On behalf of our team, we're really excited to share with you some of the smart home technologies that we've been building since we last spoke to you at I/O 2018. My name is Carl Vogel. I'm a product manager on the smart home team.
My name is Manit. I am a software engineer.
I'm Gaurav. I'm a solutions engineer on smart home.
I'd like to begin with a story. One of my friends recently purchased some smart home devices, in particular light bulbs from one company and smart plugs from a different one. And he put them in an area that he calls the downstairs. And when he gets ready for bed, he walks upstairs and he says, "Hey G, turn off the lights." Well, he was telling me that oftentimes they don't respond together. One set of lights often responds a half second or a second faster than the other. Or sometimes they just take a really long time to respond in general, or they don't respond at all. As Google and our developer community work together to grow smart home, we need to work together to solve these challenges. We believe one method is to shift processing from the cloud to the local environment. We've taken our first step in this direction to improve the experience for users like him and the millions of other users that use our products on a daily basis. We're happy to introduce that first step is the local home SDK. The local home SDK enables you to locally process and fulfill smart home commands received from the Google Assistant. We do this by inviting you to build and run your smart home business logic locally on Google Home speakers and Google Nest displays. Then, we securely give you access to the lower level radios to communicate over the local area network with your smart devices. Through this, we can together deliver substantial improvements in latency and reliability. But first, before I talk about the local home SDK, let me give you an intro to the Smart Home API and then show you how the local home SDK layers on top. The Smart Home API is the foundation of our smart home program. Let's begin with how devices are defined and integrated into the Assistant. First, developers specify a device type. This is really the what is it factor. Is it a light bulb? Is it a microwave? A camera? Device type is our method to classify the overall essence of the device in a user's home. Second, developers specify a device trait. And this really describes the overall functionality of the device. What can it do? How can users control it? Devices oftentimes have multiple traits. For example, a light bulb may have the traits on-off, brightness, and color setting. Once the device type and trait are specified, we can then bring these devices into the Assistant and specifically into our home graph using the sync intent. Home graph is our database that enables us to build a topology of the user's devices in their home. Now that the devices are defined and in our home graph, let's see what happens when a user issues a command for your device. When a user says a command such as, for example, "Hey Google, turn on the lights," we send that to the Assistant server as a waveform. And then Assistant server processes this waveform and ultimately determines which device or devices the user is trying to move into what state. Then we send that as a structured JSON payload to the developer to be processed and ultimately fulfilled. And as we see, the developer communicates with the end device. Through this very simple method to integrate devices into the Assistant and have users control them, we have grown exponentially since 2017. In fact, we work with over 30,000 unique devices among 3,500 brands. We encourage you to join us and to integrate if you haven't done so already. And a great place to start is the Smart Home 101 talk that some of our friends gave earlier this morning. Although successful by almost all accounts, cloud-to-cloud integrations have inherent limitations. We may have a Google Home speaker and a smart device within 10 feet of each other, yet this command needs to travel hundreds, if not thousands of miles before returning back to the same room. This takes time and of course provides opportunities for dropped commands. So we started to think at Google, can we leverage the fact that these are on the same local area network? The local home SDK is our method to do so. At Google, the developer experience is core to our thinking, and this deeply influenced our design tenets. With the Smart Home API being the foundation, we wanted to leverage its capabilities and layer the SDK on top as a deeper integration, not as an either-or. We also implemented what we call a come-as-you-are philosophy, in that we wanted to work with your devices as is today without requiring any firmware modifications. Lastly, we've heard from you. Thousands love the Smart Home API, and so we wanted to mirror that familiar interface onto the SDK. So with these tenets now understood, let's go ahead and revisit what happens when a user issues a command using the local home SDK. As we can see, the user still says a command and it still goes to the assistant server to be processed. However, if we know that this device is locally controllable, we'll actually send that command as a JSON payload down to the Google Home speaker or Google Nest display. We'll then pull up the appropriate developer's JavaScript file that has their smart home business logic on it to process the intent. And then we'll provide access to the lower level Wi-Fi radio to ultimately communicate with your device over the local area network. And notice, the developer still controls the smart device, but can now process and fulfill that command locally. And since we still have this cloud-to-cloud integration, we now have the cloud as a fallback. So what does adding this local path do? Well, first, it allows us to reduce the latency after a payload leaves the assistant server to less than 300 milliseconds. This will provide a very, very noticeable benefit for your users. Second, it allows us to drive the reliability that a smart home command reaches the device to well above 99.9%. And we primarily achieve this by having redundancy in the system. So the next natural question is, this sounds cool, but will this work with my device? Well, I'm happy to say this works with all the device types, including the 16 new ones that we just launched at I/O. And in particular, this is not just for Wi-Fi devices. If you use a hub or a gateway for your smart home integration, for example, a BLE hub or a Zigbee hub, you can talk locally to that hub as well. In addition, we support all the traits that you use today with the one exception of two-factor authentication. Recall from the tenets that our goal was not to require any firmware changes on the part of the developer. And so we set out to support the most popular discovery and control protocols as shown on the slide behind me. And lastly, which devices can host or run this JavaScript? Well, really happy to say here that it works with all our Google Home speakers and Google Nest displays, including the new Google Nest Hub Max. So we've talked a lot about the experience for developers, and this is I/O, of course, but what about users? What do users have to do to gain this benefit? And the answer? Absolutely nothing. Once you integrate the local home SDK, we go ahead and establish the local path for all the users that are already on your smart home project. So with that, I want to turn it over to Manit to talk more about the technical architecture.
Thank you. The smart home ecosystem today relies on developers bringing in devices that are discovered and controlled on the local network in different ways. In many cases, the application layer or the business layer logic is openly documented, but nonetheless custom. Early on, we decided to make the local home platform flexible enough such that our smart home developers would be able to leverage the platform without compromising the ability to bring out their unique features. At a high level, let's look into the elements to make this flexibility happen. We'll talk about the Google device and what's happening there. We'll talk about the overall Google infrastructure and how the Google device fits into it. And then we'll go into the specifics of Discover and Control. To give a bit of background, a few years ago, we built Chromecast. Chromecast runs on Chromium, which is the open source project behind Google Chrome. Chromecast, or more specifically, the Google Cast SDK, created a way for developers to run their code on a Google-built device. This code doesn't run natively, but rather as an app in its own container. Since we're running on something like Google Chrome, this container happens to be a browser window, and the app is JavaScript. Leveraging this browser technology, we're able to run multiple media apps in their own sandboxes securely and simultaneously. Building on the Cast foundation, we created the Local Home SDK and the Local Home platform. The Local Home SDK and the platform together are the interface between developer smart home apps and the low-level radios used to talk to smart devices. Local Home platform has two important tasks to take care of. First, interfacing with the Google Assistant such that we can leverage the Smart Home API as is. And second, to provide controlled access to socket communications using TCP, UDP, or HTTP and HTTPS protocols. I just spent a couple minutes talking about the Google Home device and how you can soon run smart home JavaScript apps on it. In order to communicate with your devices in the user's local network, we also had to build out some components in the larger smart home ecosystem with the Google Assistant and with some help from you. If you already have a cloud-to-cloud smart home integration, you'll be familiar with the actions on Google Console and Home Graph. There are some additions to both of those systems in order for you, the developer, to help your users benefit from this new local path. Let's look at the high-level flow to discover and control your devices in the user's local environment in the next two slides. Before we talk about the code that you'll write to run on Google Home, you'll need to add some data via the actions on Google Console and the cloud-to-cloud integration. In the actions on Google Console, you'll tell the Google Home how to find your devices in the user's local network. We implemented the common discovery protocols like MDNS, UDP broadcast, and UPnP. Next, you'll update the sync response to include a hint to the local home platform that will help with identifying a locally discovered device is the same device that appears in the cloud-to-cloud integration sync device list. Once the discover information is added via actions on Google Console, and you've added this hint to sync response, Google Assistant will send this information to all Google Home devices that a user is linked to. If the local home platform can match a locally discovered device to a device in the list from your cloud, we've established a local path. Great, so now we have a local path, and the user says, hey Google, turn on the lights. The request from Google Assistant is dynamically routed to a Google Home device that has claimed that local route. The JavaScript app running on the Google Home can now handle this request and can communicate with the device using application layer protocols like HTTPS or TCP and UDP sockets.
So when we set out to build the local home SDK, we wanted to make sure that developers have best experience. So let's look at the developer flow. Starting with building your application to debugging it, for certifying your application, and even launching. Like, we've taken care of the complete spectrum. And in the next few sections of the slides, we'll look into these each. So first, let's start with developing your TypeScript application that'll help us discover and control the devices locally. To help discover and control devices locally, you as a developer needs to do three key things. First, like Manit mentioned earlier, the scan config on actions on Google Console. Second, the little bit of help from your Works with integration, where you update your sync response to give us a hint that these devices may be locally controllable. And third, your TypeScript app. This is the app that will run on Google Home devices. Now, a quick note about the app itself. We've been talking about JavaScript as the app that runs on the devices, but we highly recommend developing your app in TypeScript. It's just a better developer flow. So what does this app do locally? It needs to handle two key events. First, when Google Home devices discover a device in the local network that belongs to you as a provider, we fire an identify intent, and that needs to be handled by your app. The second one is reachable devices, which is a special case of the first one, where if we have discovered a hub or a bridge device, and we'll go into the details in coming sections. And finally, when the user wants to control the device, the platform fires execute intent. And for those who are familiar with the Smart Home API, it's the same execute intent that your JavaScript receives, like your cloud endpoint receives.
Let's go into the details of what the Discover flow looks like. We've talked a lot about this Actions on Google Console. So what does it look like? In a few days, you'll be able to see this new UI, which allows you to update how we find your devices in the user's local network. In this particular example, we've added the ability to upload the UDP broadcast packet along with the in and output ports required for UDP broadcast. Next, we'll take a look at exactly what you need to do to update the sync response. We've added a new field called Other Device IDs, which hints to the Google Home to start looking for a device, and we'll use the information in this field to help deduplicate a device that we find locally to a device that you told us about via the cloud-to-cloud integration. Here's a sample of what that looks like. You'll notice that this Other Device IDs field appears at the device level. So you, as the developer, can choose which devices you want to be locally controlled or not.
So now we're going to jump into the TypeScript app, and this is the app that has the business logic that can control your devices. It is a simple, but it's a critical component in this whole process. And just a quick reminder, we need to handle two intents. Let's quickly put these intents in perspective. So for those who are familiar with the Smart Home API, we have sync, query, and execute intent that Google servers send to your cloud services. For local, we are adding two new intents. Identify, which is fired by platform when we've scanned a device that belongs to you. And second is the reachable devices intent, which is optional, but required for if we have scanned a bridge or a hub. Let's get started with the TypeScript app. But before we do that, let's look at the SDK interface. And when this launches in June, you will be able to download a sample and a boilerplate code from GitHub. So the interface exposed by the SDK is pretty straightforward. It has two main classes. First, the device manager class. The device manager class provides methods to communicate with your devices. And like Manit mentioned earlier, it could be TCP, UDP, or HTTP, HTTPS. The second is the app class. This provides the methods to attach the intent handlers. So let's look at the typings for device manager class. Here's the send, which takes in an input for command request type object and returns a promise which is resolved when command is completed. And like I said earlier, it could be HTTP, TCP, or UDP. Let's look at the typings for the app class. So for those who are familiar with the Actions on Google Node library that you use for the cloud-side integration, you will realize that there we have on execute, on sync, and on query as the handlers you can attach to. Here we have on identify, on reachable devices, and on execute methods, which you can call to attach the handlers for your app. After your app has attached the handlers, we call the listen API, and that's an indicator to the SDK that the app is now ready to process these intents. And notice that these methods are chainable. Finally, when you are ready to communicate with your device, you'll call the get device manager API to get the singleton object for device manager and use the send API. Let's put this interface into perspective by looking at the skeleton of a sample app. So in the sample app, I have like identify handler and execute handler. And in the constructor for this class, I create the instantiation of a local home app, get the device manager object, attach the two handlers, and call the listen API. Now let's start looking at the events that happen at runtime and what your app does to handle those events.
Gaurav, I'm a visual learner, so let's take a look at this in pictures. You've already updated the scan config via actions of Google Console. You've updated the sync response, and now that information has been sent down to a Google Home. The Google Home starts a state machine where we look for local devices. This process repeats, so whenever a user plugs in a new device, we'll find that too. When the smart device responds to one of our scans, the local home platform generates an intent called identify, like Gaurav has been mentioning, and we then call your app's identify handler.
So let's look at identify handler. So here's the signature of the identify handler. The input is an object of type identify request, and we expect a response to be a promise that resolves to identify response. The key information in identify request object is the scan data. And this depends upon the scan that we'd use to scan for your devices. It could be UDP, MDNS, UPnP. Identify response. The key information we'll look from identify response for the device that we just found is the verification ID. And this must match one of the other device IDs that we got from your sync response. And if we find the match, we would have established the local path. Now there are two other flags that are also important, is proxy and is local only. And they're set to false for this device if this device was an end device that we wanted to control. But what if we find a hub?
Great question, Gaurav. Similarly, when we find a hub, we'll trigger an identify intent, and is the fields is proxy and is local only will be set to true, and that will tell the local home platform to then trigger a reachable devices intent.
As the name kind of suggests, reachable devices intent is supposed to return all the devices that are reachable from this hub. The signature for the handler looks very similar to the identify request. The key information to look for in the reachable devices request object is the proxy device. This is your hub that you told us about in response for identify. Now, the response object, we expect an array of devices, and again, the key information for each one of those devices is the verification ID, and that has to match one of the other device IDs from your sync response.
Like you know, I'm a visual learner, so let's take a look at this lovely animation. We start establishing the local path with information from you via scan config, via the actions of Google Console, and the updated sync response from your cloud-to-cloud integration. Once the Google Assistant receives this information, it will send it down to all Google Home devices a user is linked to. Once the Google Home receives this information, it begins looking for devices on the local network. When a smart device responds, the Google Home generates an identify intent to the appropriate JavaScript. The JavaScript responds with a verification ID, and the local home platform does some magic to determine if there's a local path. If there is, Google Home will update the Google Assistant with this optimized route. Let's dive into the details of what that magic is. If you take a look at the first step, we've updated sync response, and you've told us via the other device IDs field that we should start looking for a device locally. Once we find a device locally, we'll ask you to give us a verification ID via the JavaScript. If we find a match between the verification ID and any one of the other device IDs field, we'll call that a deduplicated match, and we'll tell the assistant that that device can go local. If not, that's OK. We'll still go to your cloud for integration.
Great. So now that local path is available, thanks to the sync response, identify, and reachable devices, let's make sure when the user says a command, it goes local. So user says, hey, G, lights on. Assistant then sends a message to Google Home in this case, because we have established the local path, right? At that point, the platform generates execute intent. and the execute intent handler in your JavaScript app gets called. The key information to look for in the execute request object is the list of devices that the user wanted to control and the command and the control that user really wanted. Could be on, off, brightness, whatever. So your app is going to create a command for each one of those devices, or a series of commands actually, and then use the device manager send API to communicate with the device. And for your help, we have a utility builder function available that helps you create the execute response, and you can specify the success or the failure state for each one of those devices. So one thing to note here is that your app does not have direct access to IP address of the device. And we expect your app to use the command request object to communicate with the platform and eventually to your device. And so like we are showing here again, you could use TCP or UDP sockets or a HTTP, HTTPS request.
So to recap, what you need to do as a developer to develop your local smart home app that will run on a Google Home device are these steps. You'll tell the Google Home how to find your device on a user's local network via the actions on Google console. You'll update the sync response with a hint to establish this local path, and you'll write an app that will handle identify and execute intents and optionally a reachable device's intent.
Great. So moving on, now that the app is written and it's TypeScript, so let's start building and running this app. So TypeScript, simple. You're going to use the TypeScript compiler to generate the JavaScript app. And the good thing is you can use whichever module system you want. And as long as the target you choose is supported by Chrome browser, you're good to go. Because remember, this is an app that conceptually is running in a browser tab. So far, we've talked about that a JavaScript app is running in the browser, but technically, it's an HTML page, right? So look at this sample HTML. It really doesn't do much, only loads the SDK and your app. And during development, you can actually host this HTML page in your local machine or on a hosting server. And once you have that URL, go back to Actions on Google Console, and on device testing page, there is an input box for you to enter this URL. Once you save this URL, give 30 minutes for our servers to propagate this information. And at that point, if you reboot your Google Home devices, then you can imagine a tab coming up and it's loading your JavaScript app. And if all of that worked, moment of truth. Hey G, lights on. Did that work? And did it go local? Well, that question brings us to our next section.
Testing and debugging your app can be a little complex because the app is running on the Google Home device. But we've leveraged a few familiar tools to make it easier. Open Chrome Inspect on a new Chrome tab on a machine that's on the same Wi-Fi network as the Google Home device. Make sure your network doesn't block packets between devices on the same Wi-Fi, and you should see your app listed, like this image on the screen behind me. Click the Inspect link underneath your JavaScript, and you can open up DevTools to remote debug your app. But what if your app isn't in this list? Because your Actions on Google Console project is not yet in production, a few things need to be right before your code kicks into action. Let's go through that checklist. Make sure the linked user on the Google Home device has access to your Actions on Google project. Config. Make sure your sync response is updated and contains at least one other device IDs field filled in. Finally, the scan config and your app URL should be correctly entered in the Actions on Google console. Now, let's assume that all those worked and your app is loading. Let's make sure it loads without errors. To ensure that, you can look at the console section of the DevTools page. It'll look something like this if there is a problem. For Identify Handler, make sure that verification ID is correct and it matches one of the other device IDs field so that we can do the magic to go local. Next, for the execute handler, make sure that the commands are working, either TCP, UDP, or HTTP, HTTPS. And finally, make sure that you're returning a promise from each of your handlers.
So now to ensure the great user experience, it's important that the smart home integration that you just did is complete and all the golden queries work. So how do you do that? Smart Home Test Suite is your friend when it comes to testing your integration. And we're going to talk more about Smart Home Test Suite in detail in tomorrow's talk at 9:30 a.m. on stage 5, so join us. Finally, let's look at quickly the remainder of the app lifecycle. So your app works, Smart Home Test Suite says it's working, all the tests pass, and at that point, it's time to upload your JavaScript. So go back to the console, upload your JavaScript, hit save. After you feel ready, you hit the submit button, and that starts the certification process on Google's end to certify this new JavaScript and the integration. Once certified, your project launches to all the users. Once it's launched, you can manage your integration again, and Actions on Google Console is your window to doing that. You can monitor the ops dashboard. You can look at the stack driver logging for all the error logs that are happening in production on Google end. And if you find issues or errors with your JavaScript, go back to the console and again upload the version 2 of JavaScript and hit submit. If you see that in production there is a JavaScript bug and you need to roll back to a working version like V1 of your JavaScript, you can again work with us through the console to kind of help you roll back your JavaScript. So we've covered a lot of details about the complete developer flow, from writing your app to launching your app. And if you want to learn more about the tools available and for faster approval and submission process, join us at the Tools for Creating Better Smart Home talk on Thursday morning at 9:30 a.m. And now to know what's next, I'll invite Carl.
Thanks, Gaurav. So we have a busy couple months ahead of us. The link behind me, g.co/localhomesdk, is now live. So you can go ahead, visit that link to learn more, and we'll also be posting updates throughout the next couple months to that page. In just a few weeks, we'll launch the SDK into developer preview. And at this time, you'll be able to build and test your JavaScript app in the local environment and complete the self-certification program that Gaurav was talking about. And although we don't think it will take you a long time to complete this integration, we wanted to make sure we gave you plenty of time. And so we'll begin launching projects to production in October and bringing this amazing speed to users. We'd be remiss if we didn't give a big thank you to some of the partners on the slide behind me for providing engineering time and energy to test out the platform and SDK to make sure we deliver a rockstar product to you in June. So when we've talked about going local this whole talk, local execution is just the tip of the iceberg. We have much, much more in mind. I want to briefly talk about two technologies we're building that leverage local communication to improve the device setup experience and to extend the assistant even further. One of the things we've heard from users is that setup and account linking of smart devices is hard. In fact, it can take upwards of 10+ steps for users, including downloading a new app, creating a new username and password, setting up the device, taking an OTA, going back to the Google Home app or Google Assistant app to link, re-entering those credentials. It's not easy for users. And one of the other things we heard is that, and seen, is that users have a lot of apps on their phone to manage their smart home. And for all you smart home enthusiasts out there, you'll recognize this phone on the screen behind me, that you need a folder to actually manage your smart home. So we took our first step towards solving this device setup problem with GE Lighting and developing a seamless setup experience that we delivered first in the Google Smart Light Starter Kit. We gave users the ability to natively set up C by GE smart lights in the Google Home app without needing to download any additional apps. And instead of this 10+ step process, we reduced it to 3 steps and about 30 seconds. Let's take a look and see what it looks like. So when a Google Home device discovers a C by GE light, we prompt the user, would you like to set up your smart light? Then we go ahead and connect to the bulb and discover services, at which point then the bulb will begin to blink. And this will let the user know which bulb they're setting up. They click Setup and choose which room they want it to go in and give it a name. At this point, we're provisioning the bulb to the local network and registering it with Home Graph. And in just about 1 second, you'll see that the smart light is now set up. And at which point, it can go ahead and start taking Google Home commands. And so 30 seconds is really incredible for our users, and we've heard really great feedback so far. And we accomplished this by allowing GE to run their code on Google Home devices. And yes, as you may have guessed, they also used the local Home SDK. However, to do seamless setup, there's more intents to write than just the identify and execute we talked about today, including indicate, provision, unprovision, etc. And those are all part of the SDK. And also, this SDK can be used for more than just the Wi-Fi radio. As part of early access, we allow this SDK to also leverage the Bluetooth radios for direct connection to BLE devices. And through this seamless setup experience with BLE devices, we use the Google Home as a hub. So you don't need to go out and buy an additional BLE hub or gateway. We're growing this seamless setup program now and focusing on BLE devices in the near term. So if you're interested, let us know by visiting the link on the screen behind me. Next, I want to talk about Assistant Connect, which is something that you may have heard about at CES, and we've been continuing to invest in since. It leverages the same local home platform that Manit talked about to extend the reach of the Google Assistant, which we call Assistant Extensions. And we've classified these into 2 categories. The first is input extensions, which enable a simple method for a user to activate the assistant, to do everything from simple queries such as, what's the weather, to triggering advanced smart home routines. Here we have a simple programmable button that instead of always requiring users to say, hey G, they can go ahead and just push the button. It's really great for some of those frequent queries. In addition, we also have output extensions that enable devices to show assistant responses, such as what's the weather or their schedule from their Google Calendar. So this is currently in early access right now, and throughout 2019, we have a really busy year ahead of us. We have some product launches coming up later this year, so stay tuned. And our teams are finalizing the reference design and preparing the Assistant Connect SDK for public release later this year. And by 2020, we expect developers to have self-service access and the ability to even more easily and deeply integrate the assistant into their products. So to recap, we believe that driving logic from cloud to on-device is central to our strategy to create even better experiences for users. And we believe that by going local, we can also invite developers to integrate more deeply with Google. Secondly, the developer experience is key to building a great smart home ecosystem. Our ecosystem is only as strong as our developer community, you all. We've taken many steps to make onboarding as simple as possible, for example, by not requiring firmware updates to garner the benefits of local execution. And we always welcome feedback on how we can further improve, so definitely let us know. And lastly, a big focus for us in 2019 is reducing friction and making device setup and linking more seamless. I encourage you to explore our programs and learn more. So with that, I realize a 5:30 p.m. talk, you're foregoing happy hours, so we thank you for coming here today and listening to learn more about local technologies. If you have any additional questions, check out the links on the slide behind me, visit us in the sandbox, or swing by our office hours. And with that, enjoy the rest of your I.O. Thank you.